Hello everyone, welcome to solve this nice math Olympiad exponential equation problem. So here we have 7 to the power of a minus 6 to the power of a is equals to 13, and we solve this problem for all the values of a. And at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further we solve the solution in graphical representation. So please watch this video at the end. And now we move towards the solution of this problem. And here the very first thing we are going to do is here first we need to divide both of the sides of this equation by 6 to the power of a. So when we divide each of these terms by 6 to the power of a, it will becomes here 7 to the power of a divided by 6 to the power of a minus 6 to the power of a divided by 6 to the power of a equals to 13 divided by 6 to the power of a. And now here in the next step you see that this term and this term are gone, and in the first term we will use here the nice exponential rule. You know about that. If we have x to the power of m divided by y to the power of m, then we combine the exponent of both of these two terms and it will be written as x over y to the power of m. So in this way we combine the exponents of these terms and it will be written as 7 over 6 to the power of a minus 1 is equals to 13 divided by 6 to the power of a. And further in the next step here we need more simplifications. And now in order to move further, here I can explain a nice fact which is helpful to solve this problem. So you know about that if we have x to the power of m, then there are two possible cases from here. So if our x is greater than 1, then we say that x to the power of m is increasing function. Okay, so if the base term is greater than 1, then we say that the whole function is increasing. But if our x is less than 1, then we say that x power m is decreasing function. Okay, so this is the nice definition to check any function is increasing or decreasing. So according to this you see here in our case we have first we check that is our 7 over 6 is less than 1 or greater than 1. Okay, so for this here we conclude that we clearly say that 7 is greater than 6, and if our 7 is greater than 6, this means that 7 over 6 is greater than 1. So you see that from here 7 over 6 to the power of a over 7 over 6, or the base of this term is greater than 1. So according to this rule, if our x base is greater than 1, we say that the whole function is increasing function. So if the base 7 over 6 is greater than 1, this means that 7 over 6 to the power of a is increasing function. Okay, so here we write this according to the above definition of increasing function. So also you know about that when we subtract minus 1 from increasing function, so it remains increasing function. It means that our left hand side becomes increasing function. Okay, so here we need to check about the right hand side. And in the right hand side you see here we have this is 13 divided by 6 to the power of a, and if we focus on 6 to the power of a only, here we write this term also. And here we have this is 6 to the power of a, and you see here its base is 6, and we clearly see that 6 is greater than 1. This means that 6 to the power of a is also increasing function. But you know about that when this increasing function moves downward or in the denominator side, then this implies that this increasing function, then on this whole function will becomes here decreasing function. Okay, so here first we need to check that which function is increasing or decreasing. And now you see here our left hand side is increasing function and our right hand side becomes decreasing function. So if we make the graph of increasing or decreasing function, then you know about that the graph of increasing function is looks like in this form or in this way, and the graph of decreasing function is looks like in downward side. And you see here always increasing or decreasing functions are intersect at only one point. So this point is called the solution of this equation. So this point is our a. Okay, so here we need to find the point of intersection in increasing function or decreasing function. So for this we need to copy down given question statement. Here it is 7 to the power of a minus 6 to the power of a is equals to 13, and here we need to find the value of a by inspection. Okay, so here first we check at a equals to 0, and when we substitute a equals to 0, it will be written as 7 to the power of 0 minus 6 to the power of 0 equals to 13 or not. It will becomes here 1 minus 1 equals to 13, and you clearly see here 0 equals to 13. So this is not possible case. And in the same pattern we will be verify given question at a equals to 1, and when we choose a equals to 1, it will be written as 7 minus 6 is equals to 13, and it will becomes here 1 equals to 13. So this is again not possible. And if we choose a equals to 2 and we substitute this into the given question statement, it will becomes here 7 square minus 6 square equals to 13, and 7 square becomes 49 minus 6 square becomes 36 is equals to 13, and you clearly see here 13 is equals to 13. So this shows that both of the sides are equal. It means that the value of a equals to 2 is satisfied our given question statement. And we finally conclude about that the point of intersection, that is a is equals to 2. So this is our final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.